Hello and welcome to my channel. In this video we are going to solve the 8th question from CIE IGCSE 058043 extended paper from May-June 2024. Now this question is from mensuration topic. The diagram shows a solid made from a cylinder and a cone. The height of the cylinder is 16 cm and height of the cone is 1.5 cm. The radius of the cylinder and the base radius of the cone are each 0.35 cm. Calculate the total surface area of the solid. Now here in this question a solid is given to us and we can see that it is made up of a cylinder and a cone. And the base radius of the cylinder and the cone is same, that is 0.35 cm. Now to find out the total surface area of the solid, we have to consider the curved surface area of cylinder, curved surface area of the cone, and also the base area of the solid. So here let us write total surface area of solid is equal to sum of the curved surface area of cylinder, curved surface area of cone, and also the base area of this cylinder. Now the formula for curved surface area of cylinder is 2 pi RH, where R is the radius of the cylinder and H is the height of the cylinder, plus pi RL is the curved surface area of the cone as it was given over here. So R represents the radius of the cone and L is the slant height, plus base area of the cylinder. We can see that the base area is a circle, so area of the circle becomes pi r square. So here I have just separated out the cylinder and cone for easy reference. So here the height of the cylinder was given as 16 cm and the radius is 0.35, and the radius of the cone is also same, that is 0.35 cm, and height of the cone was given as 1.5 cm. Now for the curved surface area of cylinder, the radius is going to be 0.35, the height is going to be 16. But if we look at the curved surface area of the cone, the formula includes the slant height. Now here the perpendicular height of the cone is given, the radius is given, but this represents the slant height. So this inclined surface. So to find out this inclined surface, we are going to make use of a right angled triangle. That is, if we connect this perpendicular height to this radius, we get a right angled triangle. So let me separate out this triangle and draw over here. So this is the right angled triangle. This is the slant height whose value we need to find because we require for this formula. And this is the radius. Now to find out the slant height, which is the hypotenuse of this right angled triangle, we are going to make use of the Pythagoras theorem. So using Pythagoras theorem, the hypotenuse square will be equal to the sum of the square of rest two sides. So we have written here 1.5 square plus 0.35 square. Now we are going to send the square of L on the other side of equal to sign. So we get L is equal to square becomes square root of 1.5 square plus 0.35 square. So let us see what value this gives us. So this is going to give us the value as 1.5402. So here we are going to write 1.5403. I have rounded this to 4 decimal places. So 1.5403. Now this is an intermediate step. So you can take minimum 3 to 4 decimal places for more accuracy. Now once we have got this, let us substitute this value in this formula. So the total surface area of the solid is equal to, now taking this formula over here. So 2 times pi times the radius of the cylinder is 0.35 times height is 16 plus pi times r, that is radius of the cone, is 0.35 again, times the slant height, we got it as 1.5403 plus pi r square. Now this is the base area of the cylinder. So you can take pi times the radius of the cylinder is 0.35 square. Now here simplifying this, I have got the value for each of the formula. Now let us see what is the value we get when we add these numbers here. So this will give us the value as 37.2642. I'm going to round it to 1 decimal place. So I'm going to write it as 37.3 centimeters square. So this is the total surface area of the solid, 37.3 centimeters square. Now let us move on to the next sub question. Calculate the volume of the solid. So let us reconsider the figure of the solid which was given in part 1 of this question. Now here, since the solid is made up of the cylinder and the cone, we need to make use of the volume of the cylinder and volume of the cone. So when we add both the volumes, we will get the volume of the solid. So let us write down the formula now. So here volume of the solid is equal to volume of the cylinder plus volume of the cone. Now formula for volume of cylinder is pi r square h. Now since the height of the cylinder and height of the cone are different, I have named the height of the cylinder as h1 and height of the cone as h2. And the formula for volume of the cone was already given in the question. So here we have written 1 over 3 pi r square times h2. Now simply we are going to plug in the values of r, that is radius of cylinder, radius of cone, and heights of cylinder and cone. So here pi times the radius of cylinder is 0.35 square times height of the cylinder is 16 plus 1 over 3 times pi times radius of the cone is 0.35 times the perpendicular height is 1.5 centimeter. Now let us see what value this gives us. So this is the volume of the solid, that is 6.349. Now I am going to round it to 2 decimal places. So we are going to write it as 6.35. So this is the volume of the solid, that is 6.35 centimeter cube or cubic centimeter. Now let us move on to the third sub question. 10 of the solids are placed in a box in the shape of a cuboid of length 17.5 centimeter. The diagram shows one end of the box. Calculate the volume of the empty spaces in the box. Now here we can see that the front face of the box is given. It is given in the question that the box is in the shape of a cuboid. So let me first draw this as a cuboid. So here I have shown it like a cuboid. I hope you understand this. So here the front side of the box is given, that is 3.5 centimeter. The length of the box is 17.5 centimeter as shown over here. And the height of the box is 1.4 centimeter. Now there are 10 solids inside this box. And these are the same solids as we had in the previous parts of this question. Now we have to find out the volume of the empty spaces. So you can see between these circles there are some empty spaces left out. So we have to find out the volume of these spaces once we have inserted these 10 solids within this box. So for that we know that the volume of the empty space is nothing but the volume of the cuboid minus the volume of the solids which are within it. So let me write here. So volume of the empty space in the box is equal to the volume of this entire box, that is entire cuboid, minus the volume of the 10 solids which have occupied this cuboid. So let us first find out what is the volume of the cuboid. So we have the volume of the cuboid formula as length times width times height. Length here they have given as 17.5 centimeter times I have considered 3.5 as the width and height is 1.4 centimeter. So we get the value of this as 85.75 cubic centimeter. Now once we have got the volume of the cuboid, let us find out what is the volume of these 10 solids. Now volume of one solid we had got in previous part of this question as 6.35 cubic centimeter. Now since we are using 10 of these solids, we are going to get the volume of 10 solids as 10 times 6.35 cubic centimeter. So the volume of these 10 solids occupying this cuboid is 63.5 cubic centimeter. Now here we are just going to plug in the values of these two in this formula. So we have volume of the empty space in the box is equal to volume of the cuboid minus volume of 10 solids. Volume of the cuboid we got it as 85.75 minus volume of 10 solids we got it as 63.5. So this will give us the value as 22.3 cubic centimeter. So this is the volume which is left out in this cuboid after 10 solids have occupied the space. Now let us move on to the last sub question. I forgot to mention a point over here. Now 85.75 minus 63.5 will give us 22.25. I have rounded this number to 1 decimal place. So we have got the volume of empty space in the box as 22.3 cubic centimeter. Now moving on to the next one. Now this is the last sub question. The diagram shows two mathematically similar solids. The surface area of the larger solid is 200 centimeters square and the surface area of the smaller solid is 98 centimeters square. The volume of the larger solid is 450 cubic centimeter. Calculate the volume of the smaller solid. So let us first write down all the data given in this question. So here we have written the surface area of the larger solid. I have considered it as SAL, that is surface area of the larger solid, as 200 centimeters square. Surface area of the smaller solid as SAS is equal to 98 centimeters square. volume of the larger solid as VL and its value is given as 450 cubic centimeter. This is what we need to find out, that is volume of the smaller solid. Now for similar shapes, remember that we have a relationship between the volume and the area of the given shapes. So here I have written, if the shapes are similar, then the square of the ratio of volumes of the given shapes will be proportional to the cube of the ratio of areas of the given shapes. So here, since we have been given two shapes, one is the larger one and one is the smaller one, we are going to frame a ratio for volume and areas for these shapes. So using this relationship, we have written here, since we need to find out the volume of the smaller shape, I have kept it on the numerator. So volume of the smaller shape over volume of the larger shape. Now this is the ratio of the volumes and we are going to square them according to this relationship is proportional to. So the proportional symbol is being replaced by equal to sign and the ratio of areas is written as, since this is directly proportional, if we are writing in the numerator the volume of the smaller shape, on the other side we are going to write the surface area or area of the smaller shape divided by volume of the larger shape and divided by surface area of the larger shape. Now the volumes have been squared using this relationship and the surface areas have been cubed. Now here we are going to just plug in the values that's given in the question. So here we get, the square has been sent on the other side of equal to sign, so it becomes square root. The numerator Vs is written as it is, as we need to find it out, over the volume of the larger shape is 450 is equal to square root. Surface area of the smaller shape was given as 98, so we have written 98 over here, over surface area of the larger shape is 200 centimeters square. Now this is going to be cubed. Now let us take 450 on the other side of the equal to sign. So we get here Vs is equal to 450 multiplies with square root of this cube number. So let us see what value this gives us. So this is going to give us the value as, in decimals, 154.35. Now I am going to round it to one decimal place. So it becomes 154.4 cubic centimeter. So let me write here. So here the volume of the smaller shape or smaller solid is 154.4 cubic centimeter. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out these where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel, and thank you for watching.